Namaskar friends. Welcome to the educational video lecture series by MedDevice Circle. In this video lecture series, we are understanding what are the fundamentals of clinical chemistry test which are frequently used in pathology labs and IVD industry. This is important to be viewed by newcomers who have completed their education and who want to start a career in IVD industry. This is also meant to be viewed by experienced people who want to refresh their basics. And this is also intended to be viewed by our brothers and sisters who are lab technicians and who day to day work in the pathology lab. This entire video lecture series is made in collaboration with Anamol Laboratories Private Limited. So without wasting any time, let us go to our slides. Please allow me to share my screen. Friends, I hope you are able to see the screen. So as I said, this entire video lecture series is to understand the fundamentals of clinical chemistry. This video lecture series is divided into 4 different modules. In the first module, we understood the basics of photometry, in which we understood what is wavelength, what are complementary colors, what is Beer-Lambert's law, and how do we use this in our day-to-day life, what are the components of colorimeter, and what is the difference between colorimeter and spectrophotometer. In the second module, we understood what is the role of enzyme in diagnostic test, in which we understood what is the role of enzyme in human body, what are the factors that affect enzyme activity or enzyme kinetics, what are the different types of reactions in pathology lab, like endpoint reaction or kinetic reaction. We understood how to read any IFU by any company. And we also understood certain terminologies which are frequently used in pathology labs or IVD industry. All these videos are available on our YouTube channel. If you want to deep dive into these topics, please refer to those videos. In today's video, we are in module number 3. In our previous video, we understood and we discussed what is quality control SIRA and how do we use QC SIRA in our day-to-day life. In today's video, we are going to understand certain basics and fundamentals about biostatistics. So without wasting any time, let us understand what are the basics of biostatistics. But before that, let us quickly recap in 1 minute what we discussed in our previous video. In our previous video, we understood that QC SIRA or quality control SIRA are nothing but they are known value samples which are used to calculate the value of analyte in patient samples, which is an unknown value sample. They are also used to check whether the test which we have performed in the laboratory is correct or not. We use these 3 terminologies very frequently. Standard is nothing but it is a solution in which the value of the analyte is fixed, but this solution is synthetically prepared. Calibrator is a solution where the value of the analyte is fixed, but it is biological material. It is not synthetically prepared. Similarly, control is a solution in which the value of the analyte is not fixed. The value of the analyte is between a range, but it is a biological material. Now, with this brief introduction, let us understand what is the basics of biostatistics. In our previous video, we used many terminologies like target value, range, plus 2SD, minus 2SD, standard deviation. All of these terminologies we used in our previous video. Now, in this video, we will really deep dive and understand what is the meaning of these terminologies. The first terminology that we will understand in detail is something called as mean. Mean is also known as average. Now, mean is nothing but it is an average value in a particular set of values. I will just try to explain this in the form of an example. Now, say for example, you are a teacher and you are teaching the subject of science. And in your class, there are 10 students. And you are teaching science to these 10 students. Now, after you have completed teaching the syllabus, you will take a small exam. And in this exam, you will give a question paper for 10 marks. Now, let's say hypothetically, the first student scored 2 marks out of 10. The second student scored 5 marks out of 10. The third student scored 9 marks out of 10. These marks are mentioned over here. So on and so forth. The marks which is scored by each and every student is mentioned over here. So this particular 10 student exam marks are called as data points. They are also called as data set. Now, in this data set, what is the average that a particular student can score in if I teach science to that particular class? Now, that particular average is calculated by adding up all the numbers and dividing it by number of students. So, if I add 2 plus 5 plus 9 plus 3 and so on and so forth, I will get 59 as a total. If I divide 59 by number of students, so here number of student is 10, then the average of one student is 5.9. This average is called as mean. So a mean is nothing but it is a mathematically derived average. Now here it is one point is very important to understand. The average of 10 students is 5.9. Now, has any student scored 5.9 out of 10? The answer is no. None of the student has scored the marks of 5.9. Yet, the average of all the student is 5.9. So here it is important to understand that 5.9 is not an actual value. It is a mathematically derived value. Now, this value is the target value that we print on the value chart of the control. So we saw in the previous video that in the value chart for every analyte, there is a target value which is mentioned and there is a range which is mentioned. So the target value is nothing but it is the mean. How do we calculate that mean? To understand that, we need to understand how that control is being prepared. So we saw in the previous video that if I take human serum from 10 healthy people who don't have diabetes, they are healthy, they are normal people. If I take serum sample from them and if I mix the serum sample and I homogeneously mix it, and then when I calculate the value of glucose, what I will do is before mixing, I will calculate the value of glucose from all the 10 people. Suppose person number 1, the value of glucose is 100 mg per deciliter. Person number 2, the value of glucose is 80 mg per deciliter. Person number 3, the value of glucose is 120 mg per deciliter, and so on and so forth. Now, when I mix the blood and then I calculate the value of glucose, it will not come exactly as 80 or 100 or 120. It will come somewhere in between. Now, that is a mathematically derived value where if I add the value of glucose of all the 10 people and I divide it by 10, so that mathematically derived value is the mean value. So this is important to understand that it is a mathematically derived value. It is not an actual value. Now, second terminology which is important to understand is standard deviation. What is the meaning of standard deviation? In simple English, Standard deviation means that if the mean or the average is 5.9, then how far away are the individual values from 5.9? Now, friends, I have two ways of getting 5.9. I will give you a very simple example. Say, for example, I have three individuals. The first individual has glucose of 80 mg per deciliter. Second individual has glucose value of 100 mg per deciliter. And third individual has glucose value of 120 mg per deciliter. So 80, 100 and 120. If I take the average or if I calculate the mean, then the mean will come as 100. But how far away are individual values from the mean? It is only 20. That means from 100, the lowest value is 100 minus 20 and the highest value is 100 plus 20. Now there is a second way of getting 100 also. I take another three individuals. The first individual has glucose value of 60. Second individual has glucose value of 100. The third individual has glucose value of 140. Again, when I will calculate the mean will come as 100. But here, the value of 60 and 140 are far away from the mean. That means the values are scattered. So standard deviation is nothing but how far away individual values are from the point of average. That in simple English is called as standard deviation. Now the way to calculate standard deviation is given in this formula. Now don't get too much scared by looking at the formula. We will try to understand what this formula is. By the way, I forgot to tell you, mean is signified as something called as X bar. Here you can see the letter X, and on the letter X there is a dash. So this is called as X bar. Mean in mathematical language is signified as X bar, whereas standard deviation in mathematical language is signified as a Greek letter called sigma. So this is how it is signified in mathematical language. This is the uh, letter for sigma. Now we will try to understand this formula little bit in detail. Now we will use the previous example of understanding mean. Now here there are 10 students. Each student has scored some marks. The first student has scored 2 out of 10. Second student has scored 5 out of 10. Third student has scored 9 out of 10. And so on and so forth. So like this, there are 10 students and the marks of each student is mentioned over here. We understood how to calculate the mean. The mean or X bar is nothing but summation of all the students divided by number of students. So summation of all the students is 59 divided by number of students is 10. So 59 divided by 10 is 5.9. Now this 5.9 is called as mean. So to calculate standard deviation, there is a step-by-step process that I have to do. In the first step, what I have to do is I have to subtract the mean from the individual values. Here xi means individual value. So the first student has scored 2 marks out of 10. So if from 2, if I subtract 5.9, then I will get a value of minus 3.9. Similarly, from the second student who has scored 5 marks, if I subtract the average of 5.9 from 5, then I will get a value of minus 0.9. Similarly, from the third student who scored 9 marks, if I subtract the value of mean, which is 5.9, I will get the value of plus 3.1. So this exercise I will do for all the 10 students. Now, in the second step, what I will do is I will add up all these values. The difference of individual value minus the mean. I will try to take a summation of these values. But friends, this has one big problem. The problem is that certain values are in negative, minus 3.9, minus 0.9, and certain values are in positive, plus 3.1, plus 1.1, plus 2.1. Now, if I take the summation, if I add these values, then the negative value will cancel with the positive value, and I will not get the real summation. So if I have to remove the negative sign from this, what I have to do? The technical answer is I have to square the individual value and again square root it back. So when I square it, if I square 3.9, then I have to multiply, sorry, I have to multiply minus 3.9 into minus 3.9. So minus into minus becomes a plus. So here, if I square minus 3.9, I will get the value as plus 15.21. Similarly, if I square the value of minus 0.9, then minus 0.9 into minus 0.9 will become plus 0.81. So why I did the square is because I wanted to remove the negative sign. Because when I take the summation, the negative sign should not cancel the positive sign. Therefore, when I now with the square values, if I do the summation, I will get the correct value of the squared value. Okay. So here the summation of squared value is 54.9. Now this value I will enter into the formula for standard deviation. So now we will look back at the formula for standard deviation. So standard deviation is nothing but it is a square root of summation of x minus x bar whole square divided by n. So here x minus x bar whole square we calculated from the previous table. This is x minus x bar whole square. This whole square value is 54.9 in this particular example. This 54.9 we divide by the number of students. So number of students is 10. So 54.9 divided by 10 comes is 5.49. But all this is under a square root because here we squared the original values. So to get back the original value, we have to again square root it. So under root of 5.49 is 2.34. So this is how we get the value of standard deviation. Now in simple English, what it means is that if I am a teacher and I teach science to my class, I have 10 students in my class. When I take the exam and I see how many marks each student has scored, I will calculate the average. The average that a student scores is 5.9 and the standard deviation is 2.34. That means from 5.9, if I go less than 2.34, it will be called as minus 1 SD. From 5.9, if I go plus 2.34, it will be called as plus 1 SD. So on and so forth, right? Now, this is a very important scientific phenomena because if we try to plot a graph, let me show you the graph first. Like this is a graph. If we try to plot this kind of graph, what will happen is this particular value is the mean value. Let's say hypothetically this mean value is 5.9 in our previous example. From this mean value, we go to minus 1 SD. That means 5.9 minus 2.34 and 5.9 plus 2.34. So minus 1 SD and plus 1 SD is the range that we get. Similarly, from this minus 1 SD, again we go one more 1 SD. That means from this value, again we subtract 2.34. So we get minus 2 SD. Similarly, from this point of plus 2 SD, we again add one more standard deviation. That means we will add plus 2.34 again. So here we will get the value of plus 2 SD. Now, this is very important to understand because if we look at this graph, there is something which is very, very interesting which is happening. From the mean, if we go minus 1 SD and we go plus 1 SD, within that range, we will see that 68% of our students are in that range. Now from the mean, if we go minus 2 SD and we go plus 2 SD, that is the range in which 95% of our students are present. Now this is true for any kind of experiment that we do. This is a universal phenomena. Let's say I am not a teacher. I am not teaching science and I am not taking any exam. Let's say I am a scientist and I am trying to find out what is the average height of all the males in my area. So here in this experiment, if I take 100 males and I take the height of these males, if I measure the height of these males, of all the 100 males and I calculate the mean. So from mean, I will calculate the standard deviation. I will observe that from the mean, plus minus 1 SD is the range in which 68% of the males are present. That means the height of the males are between plus minus 1 SD. And 95% of the height is between plus minus 2 SD. Now, I will take a third experiment. I am not calculating the height. I am not teaching science also. Let's say I want to estimate what is the average hemoglobin values of all the females in my area. If I do this experiment, I will say I will take 500 females. I will do the estimation of hemoglobin in 500 females. Again, I will calculate the mean. I will calculate the standard deviation. I will again observe the same phenomena that from the mean within the range of plus minus 2 SD, 68% of the females will have hemoglobin values between plus minus 1 SD. And 95% females will have the hemoglobin values between plus minus 2 SD. Now, this phenomena was observed by a scientist whose name was Gauss. That is why this curve is called as Gaussian curve. This curve is also called as a bell curve because it looks like a bell. This is a universal phenomena, and that is why we always take the range of plus minus 2 SD. Now in our controls, if we recall our previous video, while deciding the value of the range of control, what we do is first we take the value of mean, and from the mean, while deciding the range, we take the value of plus minus 2 SD because between plus minus 2 SD, there is a 95% probability that I will get a value in that range only. This phenomena is used to derive the value of range in the controls. I hope this concept is now clear to you. Now, apart from this, there is also one more terminology which is called as coefficient of variation. In short, it is called as CV. Some people also call it as CV percentage. So CV percentage is nothing but it is the comparison between the standard deviation and the mean of that particular test range. How this is important to us in pathology lab? We will try to understand with the help of one example. Now let's say in a pathology lab, you want to test glucose. Okay. Now you have two different kits for testing glucose. One kit is manufactured by company A and one kit is manufactured by company B. Now, when you check that for the first kit, the standard deviation is 20. And for the second kit, the standard deviation is 30. How will you decide which kit is better? Whether kit A is better or kit B is better? Till now, it is appearing that kit A is better because kit A has less standard deviation. That means the values are more towards the center point. But wait, you are smart. You will not come to any conclusion by this information alone. Now, because you are smart, you will not only check the standard deviation of the kit, but you will also check the mean of the kit. Suppose mean of first kit is 100 and mean of second kit is 200. Now, can you think and tell me which kit is better? Is kit A better or kit B better? Now, we apply the formula of CV. In CV, what we do is we divide the standard deviation from the mean. So for kit number 1, standard deviation of 20 divided by the mean of 100 expressed in terms of a percentage will give us a CV of 20%. But for kit number B or second kit, the standard deviation of 30 divided by its mean of 200 multiply by 100 for expressing in terms of percentage will give us a CV of 15%. So now which kit is better? Is kit A better or kit B better? Practically, kit B is better because kit B has a lesser CV as compared to kit A. So this is why we use CV percentage as the deciding parameter in our pathology lab. So whenever we design any diagnostic test, we always see whether kit A is better or kit B is better on the basis of CV percentage. So CV percentage means that if kit A has the mean of 100 and it has a standard deviation of 20, when the mean of kit A will be equal to mean of kit B, that means 100 mean will become 200. Then the kit A will have a standard deviation of 40, not 30. So therefore, at higher mean value also, kit B has a shorter standard deviation. That means even though the mean is high, still the values are closer to the target value. So this is the importance of checking CV percentage in pathology lab. So friends, I hope these three common terminologies are very clear to you now because these are the three most common terminologies which you will encounter in your IVD industry. So if you have any kind of suggestion or if you have any kind of question, please write in the comment section. It will help us to improve our future videos. Thank you very much, friends, and I will see you in the next video.